Hello and a warm welcome to everyone. Welcome to our webinar today. My name is Amelia Lim, and on behalf of Kepner-Tregoe, I want to thank you for attending our webinar, 8D Problem Solving and How the German Association of the Automotive Industry, also known as VDA, recommends Kepner-Tregoe's is and is not. Now, before we dive into the presentation proper, I have a few housekeeping items just to lay out. Now, we'd love to have you engage with us, and we will ask you to participate in a few polls. As always, we would also love to answer questions that may come to your mind. Now, the polls will be initiated by our presenter throughout the presentation, and it will be fairly simple to use. So for questions, now you can simply submit these questions using the Ask a Question tab. You will find this located at just right beneath your BrightTalk player. And there will also be a Q&A section, but please do submit your questions as and when you think of them, and we will get that answered towards the end, all right? Now, in the attachments area, you will find today's presentation, details for a case study that will be presented, a link to Kepner-Tregoe's 8D services information, as well as the VDA's Red Book. Now, this attachments tab is located just next to the Ask a Question tab. Now, I'll urge you all to go there now to just take a look and make sure that you can access these materials here. And by the end of this week, we will send an email, by email, okay, a copy of the slides as well as a recorded version of this presentation. Now, please feel free to share this with your colleagues or any acquaintances you have that may be of interest or may find this webinar useful. And we would also want to know if you found this webinar valuable. So at the end, please take a moment to rate this session by clicking on the Rate This button. Now, this is also found on your BrightTalk video player. Okay, so now let's get started. Now, speaking to us from Berlin, Germany, our presenter, Mr. Burkhardt Prigge. He has been with Kepner-Tregoe since 2011. Burkhardt is an electrical engineer and an industrial engineer and is responsible for Kepner-Tregoe's services in the German market. We are excited to have him with us today, and thank you in advance for spending time with us. And I shall now turn this over to the very capable hands of our Mr. Burkhardt Prigge. Burkhardt,
thank you, Amelia, and welcome everybody. A few words about Kepner-Tregoe first. The company was founded in 1958 by Dr. Charles Kepner and Dr. Benjamin Tregoe, two American behavioral scientists who recognized that the process of successfully solving a variety of different problems can be traced back to a handful of fundamental thinking processes. We operate worldwide and convey these thinking processes to our customers through training and coaching in both face-to-face sessions and online via the internet. We also come to our customers' premises and personally moderate the analysis of the most difficult problems right there. And we advise our customers, especially on questions of how they can establish efficient problem solving in their companies. The photo, by the way, shows the rocket launch of Apollo 13 in 1970. During its journey to the moon, one of the oxygen tanks exploded, and NASA used the Kepner-Tregoe processes, among other things, to quickly find the cause for the resulting voltage drop. Actions could be taken to get the astronauts back alive to Earth just in time. Maybe you know the 1995 film with Tom Hanks, Kevin Bacon, and Ed Harris. Let us take a look at the Kepner-Tregoe thinking processes. Problem analysis is the most relevant KT process within an 8D analysis. D2 and D4 are all about describing the problem and finding root cause. But the other fundamental Kepner-Tregoe processes, like decision analysis, potential problem or potential opportunity analysis, as well as situation appraisal, also have their role within an 8D problem-solving effort. Just about 2 years ago, the VDA, which stands for Verband der Automobilindustrie, or German Association of the Automotive Industry, has published a new standard in which it recommends to its members and the automotive industry as a whole the best practice on how to conduct an 8D analysis. While I am from Germany, and you might have heard of cars made in Germany, I understand that many of you are from the APAC region. Nonetheless, many suppliers to the automotive industry worldwide need to follow standards like this, whether it be from the German VDA or from the American Automotive Industry Action Group. These two organizations have launched a joint approach to standardize good quality AT problem solving, and you find a very similar problem solving guideline from the AIAG as well. Before we take a closer look, I would like to start a quick poll. How often do you use AT analysis for problem solving? Do you always use that when you want to solve a problem? Most of the time, sometimes, or never? The poll is open, and you can go to the bottom of your screen to vote on it. How often do you use AT analysis for problem solving? We have about a half minute to go. Yeah, about 20 seconds to go before I close the poll. How often do you use AT analysis for problem solving? Ten more seconds. We get the first answers coming in. Not too many yet. All right. So I'm ending the poll. And what we see is that none of you always use AT analysis. 18% use it most of the time, though. About 63% sometimes use it. Oh, well, that changes now. So I need to restate that. 5% always use AT analysis. 25% use it most of the time. 43% sometimes, and 26% never. All right. Thank you for that. And we move on. Two key disciplines within the AT framework are D2, problem description, and D4, root cause analysis. The VDA has clear requirements for all of the 8 disciplines, but in D2 and in D4, it explicitly references Kepner-Tregoe is and is not. In each of the disciplines of an AT analysis, there are 2 levels of requirements with clear measures: the basic requirements and criteria for achieving excellence within an audit. Using is and is not is mandatory in both D2 and D4, and the VDA explicitly names Kepner-Tregoe as the source. Another poll that we are going to look at before we move on: how satisfied are you with the quality and duration of your AT analysis? I'm starting the poll now, and you have 1 minute to click the answer that applies to you. How satisfied are you with the quality and duration of your AT analysis? Are you very satisfied, somewhat dissatisfied, or very dissatisfied? Of course, if you have never used an AT analysis, if you have never conducted an AT analysis, this would be not applicable, and then you would have to vote for the 5th category. So please, again, access the voting area of your screen and cast your answer. We have about 15 seconds to go. How satisfied are you with quality and duration of your AT analysis? All right, and I'm closing the poll. Let's see what answers are coming in and if they are perhaps changing once more. I see no more change, and it seems interesting that, well, for half of you, 50% exactly, now that has changed. 37%, it's not applicable because you don't do AT analysis. And for those that do, 37% are somewhat satisfied and 25% are somewhat dissatisfied. So, well, the glass is more than half full for those that do it, but still there is room for improvement. Let's move on and take a look at a case study. I would like to use this case study to show you how the Kepner-Tregoe processes, especially is and is not, can be applied within an 8D analysis. You find the PDF of the case study here for download in the attachments to this Bright Talk. If you like, you can take a quick look into the case study, and I will also explain the key information right here for you. I give you 2 minutes time to find the file, download it, and take a look. No worries if you don't manage to read it all. I'll walk you through the details in a moment. So if you like, go to the attachment sections below your screen, and there you find a case study called Microcomputer Cabinets. You might want to download it and take a look at it. But as I said, I'm going to go through all the details with you just after this. Okay, 1 more minute to go. Okay, I hope you're all able to find the case study, and if you like, download it, get an idea of what this is about, and in a few seconds, we're going to take a look together, and I'll explain you everything that happens in that factory. Okay, 15 seconds to go. All right, let's move on. And as I said, it's just okay if you don't manage to have read everything yet, because we take a look together. So in our factory, we make 3 kinds of microcomputers: the 1025, the 1035, and the 1045. We are in the middle of a peak period, which is 6 weeks long. Production is increased each week. We make more 1025s than 1035s and 45s combined. The 1025 is produced in line 1. The 1035 and 1045 are both produced in line 2. Each line has its own supply of components, which are assembled into the computer chassis. Components are tested during assembly. While the components are being assembled, the metal cabinets go through wash, paint, and dry operations. The cabinets are washed by dipping them in a cleaning solution that removes contaminants and oils. The cleaning solution is changed every half hour. Each line has 2 wash tanks. One is used, while the other is drained and filled with fresh solution. The tanks on both lines are filled from a central supply tank. After washing, the cabinets are hung by hand on the line 1 and line 2 conveyors. The cabinets are hung from grounded hooks. Both conveyors move at the same speed through the paint booth. Electrostatically charged paint is sprayed onto the cabinets. After painting, the units enter the drying section. After drying, the cabinets go to final assembly. There, the chassis are put into the cabinets. The finished units are sent to quality control, then to shipping. Computers that are rejected in final inspection are sent to the rework sections. Over the last 2 weeks, we have a higher reject rate now for the 1025s because of gaps in the paint. The 1025 reject rate normally is 0.15%. It is currently over 6% and still rising. Every microcomputer goes through final inspection. Lately, a significant number of 1025s are being rejected periodically at final visual inspection due to gaps in the paint. A rejected cabinet may have as many as 11 different gaps in the paint coverage. These gaps appear randomly on the painted surface of the cabinets. This is frustrating for experienced people who saw the same kind of reject rate on 1025s during last year's peak period. After a few weeks, they learned that some employees were wearing a silicone hand cream, which can prevent paint from sticking. Management posted a list of acceptable hand creams in the washrooms. Within a week, the reject rate returned to normal. The reject rate for 1025s has been increasing over the last 2 weeks. The reject rate for 1035s and 45s is normal. The operation of the microcomputers is unaffected, but the units cannot be sent to customers. The rejected cabinets are stripped and repainted, so there is no increase in scrap. However, key customers are complaining about late delivery of their 1025s. How can we fix this problem? We need 8D problem solving. Let's take a look, one discipline at a time, but first, another small survey. What are the main difficulties you are experiencing during your 8D analysis? And here, multiple answers are possible. I don't have a multiple choice for you to click, but you can type into the questions section of this Bright Talk. So you find the area for questions. And if you click on that, you can enter what are the main difficulties you are experiencing during your 8D analysis. Is it that you don't find the root cause? That there is too much trial and error, the analysis takes too long, or anything else, difficulties that you experience when you try to solve technical problems with 8D. What issues, what difficulties, what problems do you face? Please take a minute and type that into the questions section. We're going to capture that and take a look at that. I'll give you 30 more seconds to enter what are the main difficulties you are experiencing during your 8D analysis. And you can give more than one answer, of course. So just go to the questions section and type in what your difficulties are. 15 seconds to go. All right. And I'm moving on. If you're still typing, you can continue typing while we go on with the Bright Talk here. Let us take a look at the first discipline. In D1, problem-solving team, it's all about identifying the sponsor, the team leader, and the team members or experts for the analysis. Here we can use Kepner-Tregoe situation appraisal, particularly the fourth step, plan involvement. Now, as we get to discipline D2, problem description, things start getting interesting. We set up the problem statement and specify the what, where, when extent in is and is not. This is genuinely Kepner-Tregoe problem analysis, particularly the first step, describe problem. In its 8D standard, the VDA requires to set up a problem specification with is and is not. Since the autumn of 2020, the VDA explicitly references Kepner-Tregoe for that. So this is what it could look like if we take the information from the case study to start a Kepner-Tregoe problem analysis and describe the problem. At the top is the problem statement. Microcomputer cabinets 1025 have paint gaps. On the left side, the is information. On the right side, the is not. Only 1025s have the problem. The 1035s and 45s are not affected. We experience paint gaps. Paint running, peeling, or discoloration are not observed. We find the paint gaps at final inspection, but we have no reports from final assembly. The paint gaps are randomly on the painted surface, not in specific places, etc. So here we specify the what, where, when extent of this problem. D3 is now about containment actions to eliminate the impact of the problem on the customer. We can use Kepner-Tregoe decision analysis to select the most appropriate containment actions. As a result, we end up with two containment actions. send microcomputers with paint gaps to the rework section, where they get stripped, washed, and returned, and inform key customers about late deliveries and adjust the shipment schedule. In D4, root cause analysis, it's now about identifying possible causes that could explain how the deviation on the object occurred, evaluating possible causes to get rid of those hypotheses that don't make sense and to determine the most probable cause, and finally, to confirm true cause. This is nothing but the 3 next steps of Kepner-Tregoe problem analysis. In the booklet, the VDA names several methods for root cause analysis and explicitly requires the continued use of is and is not. By the way, when you look at concepts like the 5 whys or in Ishikawa fishbone diagram, then these are actually tools that can help at certain substeps within the individual Kepner-Tregoe process steps. To identify possible causes, the VDA also suggests using distinctions and changes, one of the established approaches within Kepner-Tregoe problem analysis. This is what this could look like for the microcomputer cabinets. We find several distinctions and also changes. With or without distinction and changes, usually a substantial number of possible causes will be identified. I have listed only 3 of them here, just as an example. Operators use silicon hand cream, hooks are not grounded, or the cleaning solution is contaminated before the 30 minutes are over. The VDA now requires testing the possible causes by comparing them against the is and is not data. First of all, ungrounded hooks can be eliminated as the cause of this problem because they would create a different kind of deviation. That means this cause would be contradicting the problem specification. Each of the 2 other causes would basically be possible, but under a different number of assumptions with different plausibility. By looking at the previously noted assumptions, we can now determine that the hypothesis that the cleaning solution is contaminated before 30 minutes are over is the most probable cause. In the final step of the Kepner-Tregoe problem analysis, we now have to confirm true cause. This can be achieved in a variety of ways. For example, we could go to the line 1 wash tank and observe. In the final moments before the cleaning solution is replaced, it is already very dirty. The final cabinets are no longer washed properly and the paint comes out with gaps after drying. Before we move on, I have one final poll for you. And the question is, do you already use is and is not to specify a problem in your AD analysis? There are 5 possible answers. Either you always use is and is not when you specify a problem, you use it most of the time, sometimes or never, or in case you just don't do any AD analysis, well, then it does not apply to you. Please go to the voting section for a final time. And yes, then we take a look at the results. We have about half a minute to go. Do you already use is and is not to specify a problem in your AD analysis? Always, most of the time, sometimes, or never. First results are coming in, but I wait a little until it stabilizes. I'm ending the poll, but let's see what numbers are eventually coming up here. Do you already use is and is not to specify a problem? And this seems to be the final result. 17% always use is and is not when you specify a problem. Another 17% do it most of the time. Well, that has dropped to 12%. Now 12% use it most of the time. 37% sometimes, 20% never, and well, 15% it doesn't apply. So for those that only use it sometimes or never, if you do an AD analysis according to VDA regulations, you must use is and is not, and you have seen a little bit of how that could work. Moving on, In the following disciplines, we now again use some of the other KT processes. So we could use Kepner-Tregoe decision analysis in D5, selection and verification of corrective actions. For example, we might consider 4 different alternatives as corrective actions. We could increase the line speed, change the cleaning solution in line 1 wash tank every 20 minutes, use a new wash solvent, or use a new acid wash pre-treatment. Using decision analysis, we select changing the cleaning solution in the line 1 wash tank every 20 minutes as the best alternative. In D6, we now implement and validate the corrective actions. Within KT, we also call this try a fix and monitor. And we see, as soon as we start changing the cleaning solution in line 1 every 20 minutes, there are no longer any paint gaps. In D7, we now want to prevent reoccurrence. At KT, we call this think beyond the fix. To do this, we are using elements of Kepner-Tregoe potential problem analysis. We ask, what other damage could this cause create? Where else could this cause create problems? What caused the cause? And to extend the fix, what identical things need the same fix, and what problems could this fix cause? In the end, in D8, finalization and acknowledgement of team success, some elements of the Kepner-Tregoe performance system are employed. Feedback is important for continuous improvement, and we make sure that all actions from D3, D5, and D6 are finished, that the report is available and approved by the sponsor and the team leader, and that the team effort has been acknowledged. The documentation of an entire 8D analysis can be done in an A3 form. Here is an example of an A3 form that I designed for a life science enterprise in Germany. Sometimes it's actually better to print this even larger than A3. So as a conclusion, I would say the German Association of the Automotive Industry requires the use of is and is not in D2 and in D4, and therefore recommends Kepner-Tregoe. And the Kepner-Tregoe processes are useful in other disciplines as well.
Thank you, Burkhardt, for that very interesting share of how the Kepner-Tregoe is and is not is used in 8D analysis. Now, as we mentioned today, there will be a Q&A section. And what I'll do now is perhaps also consolidate some of the questions that you have posted on the question board. And perhaps, Burkhardt, you can actually help us walk through those questions that our participants have put up in the question board, right? So now, first of all, I think we can actually probably go back to the first step of D1, perhaps. Now, a lot of this is pertaining the challenges that our participants here have actually experienced during 8D analysis. A lot of questions were revolving around root cause not found, and the same problem recurs even after 8D implementation. Burkhardt, would you like to chip in helping our participants here?
Well, if root cause isn't found or the problem is reoccurring, there might be 2 different things. One is you start the analysis and you just don't have the right people with the necessary knowledge and experience, or you don't have all the data that you need. So you don't get to root cause as long as you apply a process. Of course, if you have the right people and data, but you don't apply the proper process, you also won't get to root cause. But let us assume you have done everything you wanted to do, everything you could do with the right people, and you found a cause, only to see the problem coming back. Well, that is kind of frustrating. I understand that. And that shows us that it's not so easy to get to root cause, root cause in every situation. What we must do if we have a recurring problem, we still have to apply Kepner-Tregoe problem analysis. we are looking then especially for changes that are occurring close to our reoccurrence of the problem. So if something specific happens just before a problem comes up, that might give you a clue of where the true cause of the problem might lie. But well, in any situation, if you want to find root cause, or if you find the cause of a recurring problem, go through the steps of 8D and use Kepner-Tregoe process as applicable to the individual steps. So that would be my recommendation.
Thank you, Burkhardt. Okay, pertaining to what you have mentioned earlier on, in terms of an understanding of the problem, we have another question here. Sometimes we're not clear what exactly the real problem was, and sometimes it's also due to because most of the time the parts are actually hard, to return back from abroad, from the supplier side. How do we go about addressing this kind of a situation?
Yes. So in what we call situation appraisal, before we even start problem analysis, the key is to really understand the problem. What is the thing that has something wrong with it, what we call the object, and what is the precise deviation? We must be sure that we separate any agglomerated problems where we have not only one issue, but several issues, and they all result in a part being defect. It is essential that we get a clear understanding what the problem is, and usually many times we have to take a look at the part, get the part to us, or go where the part is. But hearsay and what our clients are saying to us might be not enough to come to a true root cause. It is like running a process without the input that you need, and that is usually not going to work. So make sure you separate and clarify any unclear and lumped together accusations or reports of problems, to clearly get to one object and one deviation before you start trying to find the cause for that.
Thank you for that, Burkhardt. I think this is also what you've mentioned just now. I think with regards to separating and clarifying the information that we typically get from our, say, clients or stakeholders. This perhaps is also pertaining to some of the questions our participants had, mentioning about there's no reliable data for analysis, and it's difficult to actually obtain data, perhaps the other question here that probably Burkhardt, you can help us enlighten us. Now, there can be also difficulties in terms of collecting data, and sometimes the data is missing or widely dispersed. How do you think we can actually address this?
Well, it is important that the parties that are involved in solving the problems, that is the vendor, but also the client down the supply chain, that they work together in sharing information openly and honestly. However, even with the best effort, you might just not be able to get all the answers to every question that you are asking. There might be some data just not available because it was never recorded. And that is still okay. The Kepner-Tregoe problem analysis process is robust. It is never necessary to fill out all the boxes in the specification. Oftentimes, some data that cannot be found, we just write NMD, need more data. We try to look for it, but the process still works with a subset of the ideally available data. And you can still rule out several possible causes that still contradict the available facts, and you can still identify the most probable cause according to the information that you have. Of course, more data is desired, but it works also with a little bit less than perfect.
Thank you. And Burkhardt, yes, you have mentioned need more data, NMD. We have a couple questions here regarding what is NMD. So for those of you who have actually asked that question, yes, need more data stands for, NMD stands for need more data. All right, okay. Another question that we have here, a little bit of an extension of what we have talked about just now with regards to, information not complete. And our participant here has actually also mentioned that sometimes the defect is not stable. So how do we actually go about addressing this kind of a situation using this 8D analysis?
Well, we do have defects that are there all the time. Then we just have to look at one particular time. If the defects are not stable, if they're coming and going, and sometimes they are there, sometimes not, what we want to do is we want to record exactly the times when they occur. We want to find out what has been done to those parts just before the defect has occurred. And we want to identify any patterns in these occurrences. Are these possibly periodic, like in the microcomputer cabinets? The paint gaps occurred periodically. And then we can, of course, examine what other things happen periodically and is there a connection. Sometimes, though, the occurrence is certainly not periodic, it's just sporadic, and we cannot identify any pattern time-wise with equal intervals. At least then we would like to take a look at the environment and see what changes before or a little bit before those problems occur, and maybe what changes back so the defects disappear, and that might lead us into the direction of cause.
Right. Thank you, Burkhardt. And as we move into cause, we have a question here with regards to, yes, the cause of a problem. Now, our participant here actually asked, now there can be lots of information around and many opinions about what could be the cause of a problem. How then do you think we should, be able to filter these opinions?
Yes. So what we want to do is first gather data only, and we put that into this table that we call the problem specification. You've seen that the what, where, when, extent is and is not. Here we have specific spots for these pieces of information that we lay out and have ready as a filter eventually for those many possible causes that people identify. We can identify any number of possible causes that people can come up with. There are certain requirements if we want to phrase a possible cause, which is that the cause itself should have an object and a deviation and some explanation. So don't just say it's because of the weather, or don't just say it's the material. Be a little specific and say maybe the metal is too brittle, and that would explain that it later breaks, for example. But you can use any number of hypotheses that people suggest, and then you are testing these hypotheses against the facts that you have gathered before. And you ask, if such and such cause is the cause of my problem, how does it explain all of this is and is information? And what assumptions do I have to make to explain that? And that will allow you usually to get rid of many of the possible causes that people suggested, because here or there or somewhere, they contradict the previously collected factual information. And then you can discard them. We saw that ungrounded hooks could be discarded because it would not explain that we have a perfectly painted cabinet with just a few paint gaps. There were other causes like operators using silicone hand cream, or the wash tank solution is saturated before we change it. These two causes were still remaining under certain assumptions, but we were then able to look at the assumptions and see which has the fewer and more reasonable assumptions, and that was our most probable cause. So this is how you go about it. When you have many possible causes suggested, you just list them, and then you test them against the facts in your specification. And that's why it is so important, and the VDA demands us to specify the problem in is and is not, like we have just done.
Right, and I think that's an interesting share there. Isn't it always that we have situations where we have all kinds of opinions giving straying, pulling us in different directions, which sometimes can be quite a challenge in our search for the true cause. Another question here, an interesting one. Now, this question here pertains to this situation of these participants mentioned that their production process has actually more than 1,000 steps, and it makes the is and is not distinction change identification quite difficult. Now, what do we do, or what can we do in handling such a complicated production process?
Well, it's not unusual that a production process has many steps, but the thing that has a flaw, the object with the deviation, the part that is broken, you describe that, and you describe where first in the process have you discovered this deviation on the object. By doing that, you can exclude any later steps of the production process as causal. So that gives you already a good reduction in your scope. You don't have to specify all the steps that were done before. You just identify what is the object, what's wrong with it, where do we see it, when did it happen, and how big it is. And you write that down. And then you can, of course, look back into your process and come up with ideas in which process steps it might have gotten the problem. And yeah, as I said already, identify hypotheses and then test them against the facts. So it's not really important how many steps your process has. Just identify when first in this process you have discovered or you can observe the deviation on the object.
Thank you, Burkhardt, for enlightening us on that question. Now, well, as an addition, maybe perhaps if I could also add on. Now, yeah, you can also always maybe reach out to us if you need help in terms of handling any particular problems that you have with regards to your complicated production process, and we can actually probably sit down with you and go through your analysis if necessary, right? So now another very last, let's take two more questions. Now we have one here with regards to what you have shared earlier on, Burkhardt. Now, I think one of the participants mentioned that you have shared that Ishikawa and also fishbone methods that are used together with the KT is and is not analysis. Perhaps if you can shed a little bit of light how these other problem-solving methods are used in tandem with KT is and is not analysis.
All right. So let me first go to the 5 whys. You probably have all heard about the 5 whys. And in a simple situation, with the 5 whys, you can already get to root cause. You just keep asking why. And as long as you get answers, you might actually get to what, in fact, caused the deviation that you observe. It does happen, though, that you ask why, and the answer is, oh, we don't know. And that's really the point when you actually get started with problem analysis, when you have a deviation and you don't know the answer to the why question. That would be your trigger to get into the problem analysis if you really need to find the cause. So 5 whys are a starter of Kepner-Tregoe process. They kind of precede the application of problem analysis, and they're also like the sequel. In the end, when you have found the cause, you've seen in the step where we think beyond the fix, where we want to prevent recurrence, then we ask what caused the cause. So we go deeper, and we then again use like the 5 whys to ask, so why was it that we have increased the production so much that the washing solution did get contaminated, etc. So why and why and why in the end, until we maybe get to another problem analysis because we don't know the answer. So that's the 5 whys. But then the question was about Ishikawa or fishbone diagram. When you have specified the problem in D2 and in D4, you now want to identify possible causes. Well, there's many ways of doing that. You can ask your experts and colleagues and your vendors and your buyers what they think what the cause of the problem is. And you just brainstorm and you write them down with object deviation explanation. You can use distinctions and changes like we have lightly touched upon in this Bright Talk as well. But another method of identifying possible causes from knowledge and experience is using an Ishikawa fishbone diagram. So in 6 categories like man, machine, method, mother nature, measurement, and material, you are brainstorming contributing factors that you then can make visible in the fishbone diagram by just entering them to the bones of the fish. And people get ideas by looking at that they might not have gotten by just contemplating. So the Ishikawa fishbone diagram is a tool to increase productivity in identifying possible causes. It does not tell you which cause is the true cause, because for that you then need to test these hypotheses again against the is and is not, which this Bright Talk is all about, that we need to have is and is not for proper problem solving.
Thank you, Burkhardt. Probably, okay, our last question here. What's the minimum requirement for VDA in terms of using the is and is not?
Yeah, so in D2, it says that you must use is and is not to specify your problem. And in D4, it requires you to use the is and is not information to test possible causes against them. You are not necessarily required to use the is and is not to identify distinctions and changes, which is optional. But yes, the VDA requires people in their 8D analysis to get a minimum pass on an audit that they specify the problem with is and is not, and they use the is and is not information to test possible causes.
Right. Okay. Thank you. With that, Burkhardt, thank you very much for enlightening us and also answering some of our participants' questions on board here. Now that brings us to the wrap. Now, for those of you who may have not have your questions answered, do not fret, do not worry. We will reach out to you and to actually answer your questions that you have posted up here. With that, thank you so much, Burkhardt, for this sharing and also this informative session here. And now, as a quick wrap up, Kepner-Tregoe here, actually, we will be able to support your 8D analysis for those of you who probably have challenges in terms of, like what you've mentioned, perhaps your production process is a little bit complicated. Now, we do and also offer services in terms of whether if you would like us to do an audit of your 8D analysis, you can send us a handful of those. We also do conduct in-house workshops as well as public workshops to train your employees in terms of those who are also involved in 8D problem solving. And on top of that, we also do provide implementation support. Now, if you'd like to know more, please do check us out on this link here, Kepner-Tregoe.com/LP/8D with regards to more information on 8D analysis, okay? And on behalf of Kepner-Tregoe, Burkhardt and myself have greatly appreciated your time. And if you do have any questions or thoughts that you have on this topic, please feel free. For those of you who are in Europe, feel free to reach out to Burkhardt. And for those of you who are in Asia, in this part of the world, you can always drop me a line, Amelia. And thank you again, okay, on behalf of Kepner-Tregoe for your time. And just a quick summary here. Now, we take these sessions very seriously and would be interested to know if you have found this valuable. So if you could please use rate this button on your BrightTalk player to share with us your feedback. And on top of that, a care package will be made available for you. You can expect the recorded session as well as a recorded copy of the presentation emailed to you from my email handle, Amelia Lim. And please feel free, okay, to share this and to revisit the session if you will. And we will also provide additional articles for your review. Now, in case for those of you who are interested to have a copy of the 8D analysis, summary analysis, please let us know as well, and we can get in touch with us, and we can actually arrange for a copy to be delivered to you as well. All right. So thank you again for your time and also participation. Okay, and also for your great questions here. Thank you so much.